We're going to start graphing linear equations, and there are several ways to do this. And I'm going to start with the most basic way. It's also sort of the longest way, so it's not a way I would suggest moving forward, but it is one way that you can do it. So this is by point plotting, which means obviously the graph of a linear equation is a straight line, and it is a straight line that is made up of all of the solutions, so all of the ordered pairs that are solutions to the equation. So point plotting method is basically us finding several points and then connecting the dots. One way to find those points is basically to make up an x value, plug in an x value and see what the resulting y value is, or plug in a y value and see what the resulting x value is. So this is an example where I have an equation, x plus 5y equals 21, and I'm going to let x equals 6. So in this equation, I would replace x with 6. Notice then I get, by subtracting 6 from each side, that 5y equals 15. And then I would divide by 5 on each side to get y equals 3. So when I plugged in an x value of 6, the y value of 3 came out. This is the point that would then be on my coordinate plane. So that is one of the infinitely many solutions. I would have to do that one or two more times at least to see what the graph of my line would look like. So for this first example, we're going to make up values for x. And when I do that, I typically choose a negative value, 0, and a positive value. My hope is that when I find these 3 points, which will be ordered pairs, that when I plot them, they will make a nice straight line and they will all be in the same straight line. So here I am trying to find the y value so that my negative 2, so again I'm plugging in negative 2, but there's a negative in front of it. And if that gets confusing, think about there being a negative 1 in front of it. So it would be like a negative 1 times negative 2 plus 3. Negative 1 times negative 2 is positive 2 plus 3 gives me 5. So y would be 5. That ordered pair would be negative 2 comma 5. So 2 to the left and then 5 up, negative 2, 5. Then I would plug in 0. So y equals negative 1 times 0 plus 3. Negative 1 times 0 is 0, plus 3 is 3. So I plugged in 0, and I got 3 out, which means the point 0, comma 3, which is 0 right or left, and 3 up. And my last one, y equals negative 1 times 2 plus 3. Negative 1 times 2 is negative 2. Negative 2 plus 3 is 1. So 2 comma 1, 2 to the right, 1 up, and that is a nice straight line that will go through all of my points. So I would just connect the dots. So I have mine written in because it's hard for me to make a straight line with my stylus, but that would be the graph of the equation. Let's try this one. This was in a different form, and these are not as friendly for point plotting. So the last one, if we can go back one, you can see y was by itself. And on this one, the x and the y are on the same side. So this is that standard form we talked about earlier. I again am going to make up some values, and I'm going to be very careful this time because if I make up a value like 1, just because I've done this a lot, I know this. If I make up the wrong values, I'm going to end up with fractions, which are not so fun to graph. So I'm going to choose negative 3, 0, and 3. Negative 3, 0, and 3. So 2 times negative 3 minus 3y equals 6. 2 times negative 3 is negative 6. Minus 3y equals 6. If you need to go outside of the graph, you can, or outside of the table. Negative 6 minus 3y equals 6 is what I have right now. So I would add 6 to each side because I'm trying to get that y by itself. So negative 3y equals 12, and divide by negative 3 to get y equals negative 4. So the point negative 3 comma negative 4 is a point on my line. And now I'm going to plug in 0. This one should be a little bit easier. 2 times 0 minus 3y equals 6. 2 times 0 is 0. So basically I have negative 3y equals 6. Again, I can go out of my table. I have negative 3y equals 6. I would have to divide by negative 3 to get y is negative 2. And 0, comma, negative 2, the 0 from here, the negative 2 from here. So 0, comma, negative 2. And for 3, 2 times 3 minus 3y equals 6. 2 times 3 is 6. Again, I'm going to go outside of my table because I don't have enough room. So 6 minus 3y equals 6. I'm going to subtract 6 from each side. That gives me negative 3y equals 0. If I divide by negative 3, I'm running out of room, but I get y equals 0. So the point 3, comma 0 is also a point on my line. So notice how those make a nice straight line. And again, that is the correct line. Go ahead and try this one on your own and then press play to see how you did. So on this one, again, I'm going to choose some points. I'm going to choose negative 1, 0, and 1. So y equals 2 times negative 1 minus 4. 2 times negative 1 is negative 2. I have a minus with a negative, and those always make me a little nervous, so I'm going to keep flip change, or ching ching. So I've got negative 2 plus negative 4, which is negative 6. So that point is negative 1, comma, negative 6. Next, I'm going to plug in 0, so y equals 2 times 0 minus 4. 2 times 0 is 0, and minus 4 gives me negative 4. 0 minus 4, or plus negative 4, would be negative 4. So 0, comma, negative 4. And my last point, y equals 2 times 1 minus 4. 2 times 1 is 2, and 2 minus 4, again, I'm going to keep flip change, gives me negative 2. So 1, comma, negative 2. So I'm going to plot these points and hope they make a straight line. Negative 1, comma, negative 6 would be down here off of my graph because I ran out of room. 0, comma, negative 4 would be 0 right or left and 4 down. And 1, negative 2 would be 1 to the right and 2 down. Notice they make a nice straight line, and hopefully that looks sort of straight to you. But that is what your last one would be.